welcome to Quasar Does Astronomy. I'm your host Quasar, and today is my first video discussing a scientific topic. I'm sure many of you have heard of this topic before, and those of you savvy enough to read the title of this video know what it's about. That's right, today we'll be discussing Newton's 3 laws of motion. This particular subject felt correct to start off with because of its significance to me. When I was in 5th grade, my science teacher asked the class what each one of us wanted to learn that year. And I'm not sure where I had heard this before, and I had no idea what it was at the time, but I said Newton's 3 laws of motion. But enough for us reminiscing. Let's get to science. Newton's 3 laws of motion are best stated like this. Number 1. An object at rest will remain at rest, and an object in motion will remain in motion, unless acted upon by an outside force. Law number 2. Force is equal to mass times acceleration. F equals m times a. And number 3, for every action, there is an equal and opposite reaction. So first off, let's take a look at law number 1. Some people refer to this as the law of inertia. Inertia is basically an object's resistance to its change in velocity. What this means that anything that is sitting at rest or not moving is going to stay that way. My glass of Coke, sitting over here on my desk, is not moving. When my hand applies a force to lift it up to my mouth so I can drink it, I'm applying an outside force, and the object no longer stays still. But if I were to leave this Coke at my desk and get up and walk away, not only would my wife be extremely mad at me for leaving a glass of Coke in the room, it would sit here forever, unless something came along and moved it. I used to play baseball when I was younger. Baseball is a wonderful sport to examine when talking about forces, and I'm sure it will come up many more times in other videos. In this case, we'll think of a baseball pitcher. When a baseball pitcher throws the ball home, that ball will continue to move at the same velocity, assuming we ignore air resistance, which can be a common occurrence in introductory physics. If there was no batter or catcher, that ball will continue to move forever. Now, in an actual baseball game, we do have a catcher and a batter. If the batter doesn't hit the ball, then the catcher will catch it in his glove, and that will provide the force to stop the baseball. However, if the batter hits the baseball, they will provide enough force not only to stop the ball, but to send it back in the other direction. Let's move on to law number 2. F equals m times a. Force equals mass times acceleration. This is one of the most useful laws you'll come across. When you have a mass and you put a force on it, you get an acceleration. Now, keep in mind this refers to a net force. Hand in hand with this law is the idea of a free body diagram. If we look at the whiteboard, so here we have a free body diagram. You'll see the person on the left pushing the 1 kilogram block to the right with a force of 10 newtons. And you'll see the person on the right pushing the block to the left with a force of 5 newtons. Now this means that the net force between the two people pushing is 5 newtons this way, because it's the difference between the two forces. Now we can take these numbers and plug them into our equation F equals ma that we talked about earlier in the video. So we have our equation F equals m times a, and we can plug in for that. So we know our force is 5 newtons, and our mass is 1 kilogram, and our acceleration is a. Now, our acceleration is measured in meters per second squared. And this means that when we do the math and we divide both sides by 1, which you really don't have to do, but to give you an example, you're going to move the mass over to the other side of the equation. You'll have A is equal to 5 meters per second squared. And so that's how we calculate the force, or the acceleration on an object, knowing the force on it and its mass. And that's how you apply the second law. Last but not least is Newton's 3rd law of motion. For every action, there is an equal and opposite reaction. We experience this every day. when you walk down the street, your feet push against the ground. According to Newton's third law of motion, the ground pushes back against your feet, and this is what allows you to walk forward. Another great example is a force called normal force. If you look back at the glass of the desk that we talked about during the first law, gravitational force pulls the glass down towards the earth. But my desk is in the way, so the glass can't travel any further. The desk applies a force on the glass that is equal to the force gravity pulls down on it. This means the net force that we talked about in Law 2 is 0, and the glass doesn't experience any acceleration. So, that will wrap up this video on Newton's 3 laws of motion. If you enjoyed this video, please hit the like button and subscribe. If you have anything to add or suggestions to make, leave them in the comments below. I'm Quasar, and this has been Quasar Does Astronomy. Thank you, and keep learning.